Welcome to Study Loop.
All right, so in this problem, we're talking about carbon dating again. And so we have our exponential decay model, m equals m naught e to the kt. And from problem number 11, we have our carbon dating model in specific with its k value of natural log 0.5 over 5,730. And that value of k came from the half-life of carbon-14, being 5,730 years. So what we want to do is show that this is unreliable as a method for finding the age of a dinosaur. So imagine that the dinosaur fossil is thought to be 68 million years old. So the time is 68 million. What will happen if we substitute that number into this model? So we have m equals m naught times e to the natural log of 0.5 over 5,730 times 68 million. What you're going to put in the calculator is not the m naught, but the rest of it. And what happens is you end up with 0. Now, it's not technically 0, but as far as the calculator can handle, it thinks it's 0. So that shows us that we can't use carbon dating for something that old. So then the question is, what's the limit on carbon dating? What's the minimal or the minimum detectable? If the minimum detectable level is 0.1%, then what's the maximum age? So let's let m be 0.1% of m naught, and that would be m equals 0.001 times m naught. If we substitute that into our model, we can solve for the age. So we get, let's bring it over here, 0.001 m naught equals m naught times e to the natural log of 0.5 over 5730 times t. Let's divide both sides by m naught, and we have 0.001 equals e to the natural log of 0.5 over 5,730 times t. Now we're going to take the natural log of both sides. So the natural log of 0.001 equals the natural log of 0.5 over 5,730 times t. Now our goal is to solve for t, so we need to multiply both sides by the reciprocal of this fraction, and we will get t equals 5,730 times the natural log of 0.001 over the natural log of 0.5. And when you put that into a calculator, you get approximately 57,104. So that means that the maximum age of a fossil that you could date using carbon-14 is 57,104 years.